Okay, now let's talk about the injector nozzles themselves. So this is the end that screws into the intake port. So you got your stainless steel injector lines that connect here, but you've also got a shroud that slides over the top of this, and you got an O-ring here and an O-ring here. So the way this fuel nozzle is constructed, we actually have two orifices. The first orifice that the incoming fuel encounters is this one right here. And then there's a chamber in between, and then we have the final orifice right there that delivers the fuel into the intake port. Now, like we said earlier, this thing doesn't do any fuel metering, or in other words, proportioning the correct amount of fuel to go with the air that the engine is consuming. That's being done by the fuel injector in the bottom of the engine. And then of course the flow divider just divides evenly that metered fuel out to each cylinder. So the size of the orifice in this thing is sufficient to deal with the maximum fuel flow that this engine is ever going to see. So why do we have two orifices? So we got the first orifice followed by a chamber, and then the second orifice. The reason is so that we can partially atomize the fuel. And that's also the purpose of this shroud here. So the shroud, this line here is reference to atmospheric pressure on a normally aspirated airplane, or upper deck pressure on a turbocharged airplane, essentially turbocharger output. And this flows into the middle of this chamber. I'm not sure if you can see it here. And because you've got an O-ring here and an O-ring here, when you slide this thing on, this is a little bit stiff here, but when you slide this thing all the way on to the nozzle, then this reference line here that's connected to either static or upper deck pressure on a turbocharged engine is vented to that chamber between the two orifices. And that's what's going to partially atomize the fuel before it gets delivered to the intake port. So it basically takes a solid column of fuel, breaks it up into smaller droplets of fuel mixed with air so that it's a more burnable mixture. So that's how that works. So when do you suppose the most common time that these injector nozzles get clogged up? Well, I'll tell you when you're most likely to get a clogged nozzle, and that's when some maintenance person takes the system apart to clean the nozzles. It's really not necessary unless you know you have a plugged injector nozzle. It's not necessary to open these up for cleaning. Avgas is a perfectly good cleaning solution, or solvent, if you will. And it keeps these clean as it is. But when you take these things apart, I mean, look at the size of these orifices. It doesn't take a very large chunk of material to clog that up. So please don't take these things apart to clean them unless you know you have a clogged injector. Annual inspection time, just leave it alone unless you know there's a clogged injector nozzle. Now, the orifice for the fuel is not the only thing that could be clogged. You could also have some foreign material come in through this reference line here. And what could happen if that gets clogged up is that, keep in mind, this is the side that's in the intake port. So imagine running at partial throttle settings. That means that this side is essentially exposed to the vacuum that's in the intake manifold. If you didn't have atmospheric pressure or upper deck pressure reference to this chamber, then this first orifice over here would be exposed to the vacuum of the intake port, which would now cause this injector to flow more fuel than the other injectors in the engine. So it would throw off the balance of the fuel flow. So not only do we want to avoid clogging here of the fuel path, but also the air path as well. And that's basically how the fuel injector nozzle works on a Lycoming engine.